Hello students, let us start the class on information theory. Yesterday we were discussing about this Markov process or Markov process, and we have been assuming that all our information sources can be modeled using this particular procedure which Markov started. Let me continue the discussion of whatever we did yesterday. Today let us discuss about how to find out the entropy of the Markov source, and later on, after finding out the entropy, let us try to find out the information rate of the Markov source. So, just to have a small recapitulation, our information sources are emitting symbols, and the symbols are statistically dependent. When the symbols are statistically dependent, we have to model them in a mathematical fashion so that later on we can find out the information rate for a given source. So, as these symbols are statistically dependent, we will have to use the concepts of statistics now, where we can model the source in a state diagram, and each emission of a symbol is happening when the source changes state from one state to another state. Now that is called as transition, and the symbol emission is now having transition probability. And later on, when we consider two symbols being emitted, now there is a joint probability because the symbols are statistically dependent. So in yesterday class we had seen how an information source can be modeled in a state diagram and how a tree diagram can be written for the same state diagram, and using the tree diagram how the joint probabilities can be computed for the sequences. Sequences contain a number of symbols. So in yesterday's class we had seen how for a sequence having only two symbols, the joint probabilities can be computed. Now using the same concept, today we will see how to arrive at the entropy and the information rate of the Markov source. Assuming a Markov process to be ergodic. Now what is the meaning of ergodic? I have put a small note later on, but let me tell you now what is meant by ergodic. In statistics, there are many such terminologies as stochastic, ergodic, stationary, random, and that way. Now, yesterday I had told you the meaning of stochastic means we cannot say that the system is emitting symbols which are independent. When the symbols are statistically dependent, that process can be stochastic. But at the same time, even though we call it as a random process, it is not completely random, it is not completely erratic, or it is not completely observed. I had given enough examples yesterday regarding a stochastic process. Today let me tell you about what is meant by an ergodic process. A process which is stationary and a process which is ergodic. These are the two things which are in contrast. For example, now the whole of earth is being affected by this coronavirus, and on whole of the earth human beings are really bothered about how it is going to affect their lives. But what about the other birds and animals which are there on this earth? For the other birds and animals which are there on this earth, is there any such tension or is there any such problem of attending online classes, later on thinking about offline classes, not able to move freely anywhere? Always if we move, we have to keep wearing masks, and we should keep social distance, and we should keep on sanitizing. Now, the other birds and animals are not at all affected by this particular pandemic. Why? because this pandemic is being created by human beings and the pandemic is being spread by human beings. Now we can say the process which is occurring with other birds and animals is called a stationary process, whereas the process that is occurring with the human beings on the earth is called as an ergodic process. Now what does it mean? It means that tomorrow morning when the morning sunrise happens, the same birds and animals, they will have a normal life as today. And they will have same normal life as they will have day after tomorrow as they had tomorrow. Their days are not going to change much. That means with respect to time, if the process is not actually having any lot of variation, if the process is happening in the same way day in and day out, then that is called as a stationary process. In the case of birds and animals, sunrise happens, sunset happens, again daybreak happens, and gradually one by one, whatever happened yesterday will happen today, whatever happened today will happen tomorrow in the case of those natural birds and animals. But in the case of human beings, right from the month of March, we keep on counting the number of days: April, May, June, July, August, September. We don't know when this pandemic is going to end, and there is uncertainty all over the globe. There are so many job related issues, there are so many finance related issues, there are so many health related issues. Some are hyped by the media. The truth is corrupted by the media to some extent. The truth is corrupted by the human beings also to some extent. Which means now the process is an ergodic process. Which means the one which keeps on changing even with respect to time. Now that is the stochastic anyhow. Now stochastic, how do we have a measurement for that? Even for a stochastic process, we should have a measurement for that. So that measurement, we can rename the same stochastic process in a different way as ergodic process, where we can apply the time averages. Now as far as this pandemic is concerned, we can apply a statistical measurement for the same spreading of the pandemic in such a way that in which countries it is increasing still and what is the reason for it increasing, and in which countries it has remained stable and for what reason it has remained stable, in which countries it is reducing and for what reason it has reduced. For example, in China it has reduced, whereas in USA it is increasing. Now there can be definite reasons for this increase or reduce, and to some extent immunity within the body can be increased by means of the regular physical exercise or by means of ingesting of the herbal medicines which are proved to increase the immunity of the body. For example, in Ayurveda we have Chavanaprasha, in Ayurveda we have one more Arishta called Dashamula Arishta, and in Ayurveda we have one more thing called Guduchi. These are the items which are proved to increase the immunity of the human body since thousands of years, not just few centuries. It has been proved since last 3000, 4000 years. Whatever is time tested does not require any further research or trials. Whatever is not time tested requires more and more trials. That is where in all other countries they are really worried about whether this will be controlled or not. Whereas the death rate in India is much lesser compared to the death rate that is happening in some of the Western countries, because in the Indian cooking itself, there are a lot of ingredients which are regularly used to increase the immunity of the body. So can we say that the stochastic process which is there all around the globe can be called as an ergodic process in India? I'm just giving a live example and I'm just sharing my thought process. Now what is a stochastic process? Stochastic process is the one in which the symbols are emitted dependently, or the symbols which are emitted by the process are statistically dependent. So we cannot simply have a complete predictability of the emission of symbols. but we can model that using a Markov source. Now, after we model, again we have two challenges. Whether this process is stationary or ergodic. When we modeled a stochastic process using the state diagram, we did not worry about its time dependency. Now, we know that in real life, time plays a major role. January is not same as February, February is not same as March as far as human beings are concerned. In general, every year, August, one new academic year starts, and in every year, May or June, that new academic year ends as far as the students and teachers are concerned. Whereas in businesses, every year by the end of March 31st, one financial year ends, and by April 1st, one more new financial year starts. This is as far as the businesses are concerned. Now, as far as the cold countries are concerned, every year during Christmas, they will go for a winter vacation, almost for 15 days to 1 month, they will go for a bigger vacation so that the countries are affected by heavy cold. And later on, they resume their lifestyle after January. So, in the case of human life, January is not same as February, February is not same as March, March is not same as April, and it goes on like that. Whereas in case of the normal or natural birds and animals which are there in open nature, for them these months may not matter much. Where spring, summer, autumn, winter happens as it is by a natural cycle, and then we can say that if time does not play a major role there, then we can say that it is a stationary process as such. Now, in the case of urbanites or civilized human beings, we cannot say that it is a stationary process. We have to say that the process which is occurring in our lives is ergodic. Now, we should consider time into our activities, and we should have a time average. So, a stochastic process with the time averages can be called as an ergodic process. I hope you got it now. A stochastic process with the time averages is called as an ergodic process. Means in a stochastic process, the changes that occur are averaged over a period of time, then it is called as an ergodic process. Let me give one more example. Even in case of the human beings who are living as aboriginals, for example, the people who are living in Andaman and Nicobar Islands, the people who are living isolated from the normal human population, or the people who are staying in Karnataka state in some areas called Bilgirarangana Betta, where there is a tribe called Soligas. The Soliga tribe is not in touch with the civilized human population. So, in that case, no one goes to the Soliga camp, and Soligas will not come to meet the other humans. So, naturally, the Soliga tribes are completely isolated from the mainstream. In that case, the Soliga's life, we can call it as a stationary process. Whereas a life in Bengaluru city, we can call it as a stochastic process which has to be ergodic. Actually, both are stochastic only. Even Soliga's life is also stochastic, and Bengaluru's life also is stochastic, because there is randomness everywhere. But in case of Soliga's life, it can be a stationary process. That means day in and day out, there may not be any great change in the lifestyle. Whereas in the Bengaluru lifestyle, every day some new challenge, every day some new issue, or every day some new solution. Whenever there is an issue, a solution is going to be found somehow. Now, we have to average all these events that are occurring with respect to time. That is called as ergodic process. Which means, if we can take enough precautions for the daily changes that are occurring, or if we can have ready solutions for the daily issues that we are facing, then we can say that the Bengaluru life is an ergodic process, whereas the life in Bilgirarangana Betta for Soligas can be a stationary process. I hope now it is clear about what is the meaning of the term ergodic. Unless this is clear, later on whatever we are going to do will not have more clarity for you. That is why I took some time to discuss about what is the meaning of ergodic process. Now let us say, assuming an arc of process to be ergodic means we have to take time averages for the given emission of symbols. The entropy of the source can be defined as a weighted average of the entropy of the symbols emitted from each state. Now we have a challenge of computing the entropy for this stochastic process, right? Now let us consider it as ergodic. That means we will apply time averages for the process. How we apply time averages we will see in the next exercise. Now the entropy of the source can be defined as the weighted average of the entropy of the symbols emitted from each state. We already know that the entropy is computed from the probability of the symbols. Now we have to compute the entropy for this stochastic ergodic process. Now we can define the entropy as the weighted average, because we are applying time average now. Weighted average of the entropy of the symbols emitted from each state. At each state, when there is a transition, it is going to emit symbols. Now all those entropies can be averaged with the weight, and that weighting or weighing is with respect to time. Let me proceed. Now the entropy of each state is given by capital H, Hi equals summation of j equals 1 to n of Pij Lg of 1 over Pij bits per symbol. In the earlier discussion, we did not consider this Pij. We never bothered about joint probability because it was a preliminary discussion at that time. But now we know that the emission of symbols is statistically dependent. So we should consider the joint probability now. So when we consider the joint probability, the definition remains the same, as entropy is the summation of j equals 1 to n of Pij Lg of 1 over Pij. The only difference here is, instead of the individual probability, we are now considering the joint probability. That is the entropy of each state now. Now, entropy of the source is given by H equals summation of I equals 1 to n of capital Pi, capital Hi for a first order source. Later on I will discuss about what is meant by a first order source and a second order source or a third order source. We have exercises for that later on. Now the entropy of the source is given by summation of I equals 1 to n of capital P. Remember, we have been using capital P since yesterday. Capital Pi into capital Hi for a first order source. This is nothing but summation of I equals 1 to n of capital Pi into summation of j equals 1 to n of Pij Lg of 1 over Pij bits per symbol, because we have defined the entropy of each state now in terms of joint probability. Now what is this capital Pi? The one which we computed yesterday using the tree diagrams also. So now, if you get confused here, don't worry. When we solve exercises, you will understand it better. So now, let me proceed. I have written a note here. Stationary process implies that its statistics are not affected by a shift in time origin. Ergodic process implies that the time averages can be applied on it. So, understand this. This is what I have been telling since I started this class. That is, Pi of k equals Pi of k plus j for any value of k and j. That means time averaging can be applied even to a stochastic process. That is how we make this assumption. But in a stationary process, this is not required. The Pi of k plus j is also not required, because it is going to remain the same anyhow in case of a stationary process. For a Soliga person who is living in Bilgirrangana hills, Today, tomorrow, day after tomorrow, yesterday, day before yesterday, it is the same type of lifestyle. There is not going to be any change. He will go to the forest, he will bring some honey from the forest, or he will dig into the earth and he will get some radishes or carrots or tubers, some tubers, sweet potatoes, something like that. Their life is going to remain the same whole of the year, so as to say. But the people who are living in the urban area, our lives are not the same every day. But when we apply the time averages, we can call it as an ergodic process. There is a small theorem now. Let me discuss this theorem. The proof of this theorem is beyond our scope because the proof is highly mathematical. We are only discussing the theorem. Let P of Mi be the probability of a sequence Mi of n symbols from the source. Let me consider this word probability itself. Just for the sake of an example, let me consider this word probability itself. Now let us consider this probability itself is a sequence Mi and which is containing n symbols from the source. Now this word probability is right now having 1, 2, 3, 4, 5, 6, 7, 8, 9 distinct symbols because I is repeating again here. If I is repeating, again B is repeating. Apart from B repeating and I repeating, all others are existing single. So, out of 3 plus 3 plus 3 plus 2. So, 11 minus 2 because B is occurring twice and I is occurring twice. I can say this word probability is right now containing 9 symbols out of the 26 symbols. But here, this capital N is all the symbols that are present in the information source. Means a sequence, if it is a very lengthy sequence, it can contain all the 26 symbols. If there is a lengthy word in English, the lengthiest word in English is called as pneumono ultra microscopic stereoconiosis, something like that. I don't recall the word fully now. I recalled it now. Pneumono ultra microscopic silicovolcanoconiosis. This is a very lengthy English word. I'll repeat it once again. The lengthiest English word is pneumono ultra microscopic silicovolcanoconiosis. The meaning of this word is this is a particular disease which affects the lungs of the people who work inside the mines. The people who work inside the mines, they keep on breathing stale air or the air which is filled with dust particles. If they don't have proper precautionary measures, then their lungs will get affected by a particular disease. That disease is called as pneumono ultra microscopic silicovolcanoconiosis. Volcano means mine, silico means sand, pneumono means lungs. Ultra microscopic you already know. It is affected by very minute particles. Now imagine this particular word pneumono ultra microscopic silicovolcanoconiosis. Now this is a sequence. Now this particular word can contain almost all 26 alphabets. Of course, it is not having all the 26 alphabets. You can write down this word on your own later on and you can count the number of alphabets in that particular word and you can find out which are repeating there. Now, whenever we have a sequence Mi, that means a sequence can be much lengthy and it can contain all n symbols. Here I gave an example of this word probability, or I gave an example of a much bigger word called, again, I am happy to repeat it once again, pneumono ultra microscopic silicovolcanoconiosis. So there, it may contain all the 26 alphabets. Any bigger sequence which contains all 26 alphabets is what is assumed here. Why we assume that way? We assume that way because source will keep on emitting symbols continuously when it is under the mode of transmission. Now, we cannot predict the length of sequences always. For example, when I write these notes, I cannot predict the length of a sentence always, because sentence should be meaningful. And I cannot predict that this particular sentence should have only these many words. That also I cannot predict. But later on, using MS Word software, I can count the number of words which are there in the document, or I can count the number of sentences also, or I can count the number of characters also. It is possible later on. But while I am writing the notes, I should not think much about how many words a sentence should contain and how many sentences this page should contain. I should not worry, because then the natural flow of information is lost. Same way, let P of Mi be the probability of a sequence Mi of n symbols from the source, because source keeps on emitting symbols and the symbols can occur in large numbers and that can become a sequence. That is the idea here. Then now the average information content per symbol in messages containing n symbols is given by. Now we have a bigger challenge of finding out the entropy of all these sequences which are quite lengthy. So what we can define is, we can define the average information content with a different notation called Gn. For entropy, we have been using the representation of H. Now we are using a different representation called G. I will tell you why we are using this different representation. How is it different from entropy? That we will see later on. So this average information content per symbol in messages containing n symbols is given by Gn equals 1 over n to summation of P of Mi into Lg of 1 over P of Mi. The classical definition of entropy remains the same. Now this Gn is a monotonic decreasing function of n, and limit of n tending to infinity of Gn equals h bits per symbol. What does it mean? This means that the information source is going to emit sequences. Now the sequences can be very lengthy. Even though the sequences can be very lengthy, they contain only n alphabets. For example, this English word which I told you, pneumono ultramicroscopic silicovolcanoconiosis, that is a very lengthy word. Maybe this word is lengthy, but it has to contain only the 26 alphabets. Any word in English has to contain only 26 alphabets. Which means, when we discuss the sequences, if n is tending to infinity, imagine instead of 26, let us say we have more number of alphabets in English language. Instead of 26, now in Kannada we have 50 alphabets. In Sanskrit we have 51 alphabets. In different languages we can have different set of alphabets. If you relate them to symbols, when the number of symbols increases, what is going to happen? When the number of symbols are going to increase, we should not come to a presumption that entropy is also going to increase. That is the essence of this particular theorem. I will repeat this once again. Let us say if a language is having 25 alphabets, and let us say another language is having 50 alphabets, let us say a third language is having 75 alphabets, let us say a fourth language is having 100 alphabets. Now that n is varying for each language. In the fourth language, n is 100. In the very first language, n is 25. That means n is increasing. When the n is increasing, it doesn't mean that the information is increasing. Please understand this. Information is what? Something that is unknown. That something that is unknown can be known with the least effort also, with the most effort also. I'll tell you a small joke. Information can be known with the least effort or the most effort. In a party, one lady was introducing a boy. when the lady was introducing a boy, lady told, his mother is the only daughter of my mother. His mother is the only daughter of my mother. She can simply say that he is my son. Okay. She can simply say that he is my son. Instead, she told his mother is the only daughter of my mother. This is complicating things. Only daughter of my mother is who? Me only, that lady only. His mother is who then? Me only. So she can simply say, he is my son. Instead, she told, his mother is the only daughter of my mother. That means she wanted to say that for her mother, she was the only daughter. Now, is the information content increased by complicating the sentence? No. That is why Rabindranath Tagore had told, and the same way in a movie, Rajesh Khanna had told the same sentence. In a movie called Anand, Rajesh Khanna has told the sentence. It is so simple to be happy, but it is so difficult to be simple. This is what Rabindranath Tagore had told. It is so simple to be happy, but it is so difficult to be simple. Now look at this theorem in the information theory. Here it directly says more and more number of symbols is not going to increase the information content. The information content is going to remain h bits per symbol only. Now the language which is having only 25 alphabets, language which is having 100 alphabets. In both of those languages, there may be more number of alphabets we are utilized for constructing more number of words. But somebody will say water, somebody will say pani, somebody will say niru, somebody will say tanni, somebody will say jalam. Information is same. For the same thing, people will use different types of words, but the information essentially is the same. So the outcome of the theorem now is that if the number of symbols increase, it doesn't mean that the information content increases. Otherwise, naturally we should think that if n is tending to infinity, h also should be tending to infinity, or this gn also should be tending to infinity. We should think that way, right? Now you understand why we are using different symbols like g and h. When we discussed h, we did not bother much about the sequence length, isn't it? Yesterday we had an exercise where we took example of two symbols as one sequence, but the sequence length we did not bother much there. But in a real information source, even the sequence length becomes important. Anyhow, I have been telling you that you are going to study one course called routing and switching in our center of excellence, where you are going to study something called packet switching, where information sent in terms of packets. Now each packet will have one header information and data bits and trailing bits. There is a protocol there. So that packet is a sequence of symbols. There are only two symbols there, only 0 and 1. It's a binary information there, binary source basically. Any digital communication system is basically a binary source. It is going to emit only 0 and 1. So then the packet will contain many number of bits, and with each type of communication, the number of bits which are contained in a frame is different. For example, in 2G, the number of bits which are contained in a frame can be different. In 3G, it is again different. For each and every type of communication system, they define the number of bits which have to be present in a given frame or a given packet as such. So, why I am giving this example is, we will be transmitting thousands of bits or lakhs of bits per second. We are dealing with gigabits per second and terabits per second. Now visualize the binary information which is being transmitted in a wired channel or in a wireless channel, and you can visualize the number of radio waves moving. And in a second, how many symbols are moving. You are going to study one course in the next semester called Digital Communication. And in that course, you are going to study about the digital modulation techniques such as amplitude shift keying, frequency shift keying, phase shift keying, minimum shift keying, quadrature amplitude modulation, quadrature phase shift keying, Gaussian minimum shift keying. These are all different methodologies of transmitting binary information using a radio wave. Now, whenever you transmit these bits using a radio wave, you can visualize how many radio waves are going out with the different phases, with the different amplitudes, with different frequencies. Now, those are all lengthy sequences. Now, it doesn't mean that if the sequence is lengthy and if the number of symbols used in that sequence are more, it doesn't mean that the information content is increasing. In fact, it is reducing. It is not increasing, it is reducing. Okay, that is why I told you the proof of this theorem is beyond the scope of our course as such now. The proof is completely mathematical, related to information theory itself. But you should know this theorem because based on this theorem, we are going to work out some more exercises. So, now again, look at this sentence. Gn is a monotonic decreasing function of n. Please understand this. Whenever we consider lengthy sequences, and for the lengthy sequences, whenever we compute the information content, Gn is a monotonic decreasing function of n, because when n increases, Gn is going to reduce and the limit is h. Means there is a limit where if n tends to infinity, then Gn tends to h itself. So, I repeat this sentence for the last time now. Don't think that if a language contains more number of alphabets, then it doesn't mean that it can convey more amount of information. It is not that way. Irrespective of the number of alphabets which are contained in a language, information is defined as the thing that is unknown. That's all, which can be made to known in many ways. I'll give a last example now for this particular sake only, that in China or in Japanese, they have three types of language. Three types of language itself called hiragana, katakana and kanji. Chinese also use it, Japanese also use it. And they convey the same type of information using these three mechanisms or three types of symbolic representations. Hiragana, katakana, kanji. Kanji is nothing but a set of symbols which are used to convey some pictorial information or graphical information. Instead of writing water as W-A-T-E-R, they may have a simple symbol of water, simple symbol of some waves, and that itself they will call it as kanji. And there are more than around 3000 kanji in Chinese language. That there are more than 3000 symbols. Now think about, we electronics engineers, what all symbols we use? We use symbols for passive devices, we use symbols for active devices, we use symbols for MOSFET separately, BJT separately, we use symbols for voltage sources, current sources, and we use symbols for many other things. And in maths also, we have different types of symbols. At the most, in our engineering education, electronics engineering education, at the most we may be using around 50 symbols. Now think about these kanji which is used in China, where there are nearly 3000 symbols. But does it mean that when they have more symbols, are they conveying more information? No. But why they use more symbols? For the sake of convenience. For the sake of convenience, they have more symbols. That's all. With more symbols, there can be a saving of the resources. That's all. But it does not mean that they convey large amount of information. That is the essence of this particular discussion now. So Gn is a monotonic decreasing function of n. Limit of n tending to infinity of Gn is nothing but h bits per symbol. H bits per symbol itself is the amount of entropy that is emitted, right? H bits per symbol is basically what? It is basically the entropy of the source, which we can calculate using the tree diagram. Now what Gn is what? Gn is considering the length of the sequences, okay, which we did not consider in yesterday's example. Okay, now let us have an exercise. I don't think I will be able to complete this exercise today because it is some last 4 minutes now, but let me discuss at least this example. A discrete ergodic Markov random process is represented. See, ergodic Markov random process. Random means stochastic process, statistically dependent. Why it is called as Markov? The random process is modeled using Markov's characteristics. And what is ergodic? Ergodic means the complete process is time averaged. And why is it discrete? Discrete means it is emitting symbols one after the other. The term discrete typically means it cannot emit two symbols at once. It has to emit symbols one after the other only. That is why always we consider discrete source. Why we don't consider an analog source? An analog source is a continuously varying source. In an analog source, there can be a transmission of simultaneous symbols. Nature is as such like that, no? Nature is basically analog source. In the sense, in nature, you can have a pigeon also making a noise, you can have a crow also making a noise, you can have a stray dog also making a noise. Along with that, Arvinda sir is also making a noise. This way, in nature, there can be multiple information simultaneously present. That means there is multiple symbols being emitted at the same time. We cannot model that particular source so easily. Now you appreciate Claude Shannon again and again, why he specifically chose only the digital and discrete type of information, and through that only gradually digital communication evolved. Thanks to Claude Shannon, now me and you are able to communicate without being physically in front of each other. This is basically because of Claude Shannon, where from my side to your destination, information is moving now in the form of radio waves, in the form of electrical signals, and even in the laptop we have a source coder, channel coder. Even in your mobile phone or in your laptop, you will have a channel decoder, source decoder. In the next module, I am going to show you the block diagram of the digital communication system. So this way, an ergodic discrete Markov random process is represented. Why I told we should thank Claude Shannon? Because it is not 100% possible to model a complete natural information source, but he defined it as a discrete, imagining that symbols go one after the other. Actually, our digital communication channel is discrete, which means we either send a 0 or send a 1 or send a 0 or send a 1. We cannot send 0 and 1 both together in a serial communication in a wire. Even in a wireless channel, first 0 goes, then 1 goes, or a sequence of zeros and ones keep going. But it is always discrete. 0 and 1 will together not go. That is why it is called discrete. Other things you already know. Ergodic, Markov random process, Now let me discuss this exercise only in the next class, because time is up now. In the next class again I slightly repeat this definition, then let us try to solve this exercise in the next class. Until then, take care and bye-bye.